Many people dream of traveling through space and perhaps even encountering extraterrestrial life. Evidence for higher life forms is lacking, although single-celled organisms are conceivable. Fungi, bacteria, and viruses have taken up residence on the International Space Station, the ISS, and are getting along frighteningly well. But microbes follow humans, not the other way around. The basis for the life as we know it is a liquid water. Ultimately, we humans are made up of 80 to 85% water. We need to drink about 2 liters a day. Life without liquid water is hardly imaginable. Even single-celled organisms usually swim in water. Viruses do not necessarily need water, but they only exist where there are life forms they can infect. Thus, viruses are also indirectly dependent on liquid water. But do the stars hold water at all? In contrast to the Earth, our moon and the other planets have an extraordinarily hard time with liquid water. Mars is no exception. Now, you can find out why. If you like our videos, feel free to support us with a thumbs up. Subscribe to Simply Space, and get ready for many more fascinating videos in the future. The Moon, the first extraterrestrial seaside destination full of ice. Johann Kepler thought about a journey to the Moon as early as the 16th century. This clever man, born in 1571, was not only an astronomer, mathematician, and physicist. No, he also liked to philosophize about nature and considered the sun to be the center that overcomes the laziness of the planets and forces them into orbits. Even then, he thought about gravity without knowing the concept existed. He assumed that it would be difficult to leave Earth to go to the Moon. Halfway there, the journey becomes easier, he also surmised. 400 years later, going to the Moon was almost old hat, albeit very expensive. There had already been 8 humans on the Moon out of a total of 12 so far. In 1969, the first crew was launched into orbit in a lunar rocket. Translunar injection is the name of the maneuver in which the rocket overcomes the Earth's gravity by firing again until, halfway there, it is caught by the Moon's gravity and hurtles towards it, making the journey much easier. On July 21, 1969, Neil Armstrong became the first man to set foot on the Moon, opening a new chapter for humanity. One small step for a man, one giant leap for mankind. But the first 12 visitors to the Moon also discovered that, in addition to magnificent views of the Earth, there were mainly rocks there. That there could be water there seemed inconceivable. 40 years later, however, water was detected in the rock samples brought back from the Moon. And in the meantime, even large quantities of ice are suspected deep in the lunar craters. But liquid water does not exist on the Moon. The Earth, the essential location for us humans, and full of liquid water. The first astronaut said, "We went to the Moon, but we actually discovered Earth." In fact, the view of Earth from the Moon is one of the most important images changing thinking in the 20th century. To be outside looking down at the Earth is a mind-bending experience. We saw it and rediscovered it. But interest in going to the Moon declined because mankind had done it, and probably nobody really knew how to use the Moon for mankind. And here again, people saw exactly what it costs to put people on the Moon. It was simply too expensive. Keeping the Earth clean and habitable came to the forefront, where it still is. Mars, our nearest neighbor? People's dreams turned more towards Mars after that. The red planet is the 4th from the Sun, and thus, our outer nearest neighbor. Mankind has been dreaming intensively of a trip to Mars ever since the first humans set foot on the Moon. However, it is notable that the planning of the dreams has not come to fruition in 30 years, despite what we initially thought. But many experiments have already been conducted on Earth with regard to a trip to Mars. A psychological experiment completed a few years ago was designed to show how people react when they are confined together in a small space for 3 years. It would probably take that long to travel there and back. It would depend a lot on where Mars was at the time in relation to the Earth. Unfortunately, The optimal time for a Mars expedition with the shortest trajectory passed a few years ago. Mars is coming back, but it will take some time. After all, the distance between Earth and Mars is expected to decrease a bit in the next 25,000 years. This has no practical meaning for the Mars journey. It'll still take years of time. Theoretically, Mars colonization is now actually conceivable, but it would take a bit more than a few drops of water. Venus, our closest neighbor with minimal water vapor. To Venus, the second planet, it would be a shorter trip. It is really our nearest neighbor and our inner, direct neighbor. A paltry 25 million miles away, but still 10 million miles closer than Mars. Nevertheless, mankind has become more and more interested in Mars. Although it wasn't because they knew that Venus is tremendously hot. Water would evaporate there. However, investigations show that the dry planet of today has a water-rich past. Water vapor occurs in small quantities in the atmosphere, but it's assumed that solar wind has extracted and is still extracting water from Venus. Mars and its water supplies. What about water on Mars? Why can't there be liquid water on the Moon, and why is water disappearing on Venus? Does Mars have the same problem? Among other things, it has to do with the atmosphere. The Moon has no atmosphere, and therefore liquid water would disappear into space. Venus has a thin atmosphere that can't hold the water either. Mars's atmosphere is a CO2 atmosphere, but also contains some water vapor. Again, it is thought that the Martian atmosphere is too thin for liquid water to exist on the planet for any length of time. Reports on the planet are similar. Water vapor in the atmosphere, ice inside the planet, but liquid water on the planet's surface is unlikely to exist. Nevertheless, the internet is full of reports about liquid water on Mars. Dark streaks, Mars rivers of water, or simply dust. In 2010, fleeting dark streaks were first detected on Mars. Based on the movement of these streaks, they appeared, grew longer, and then disappeared during the warm season. They were thought to be water running down Martian slopes. In 2015, it was reported they must be salt water. So-called perchlorates supposedly lowered the freezing point of water, like our antifreeze. In 2017, however, the same streaks were reinterpreted as dust flows after being observed with an improved camera. Beneath the surface of Mars, Martian lakes. In 2018, researchers described a large lake under the red planet's south pole. The radar of the so-called Mars Express, a European unmanned spacecraft orbiting Mars, is responsible for this discovery. It is based on indirect observation, the reflection of radio waves. In 2020, 3 more such lakes were described. The lakes, which are said to extend over 46,000 miles, are hypothesized to consist of salt water. And what do you think? Few things are as exciting and at the same time as critical as space exploration. The decision to focus initially on unmanned spaceflight was the right one. No one wanted to take the risk of losing people up there. And the idea of letting robots and machines take the initial passes at informing us about what's really going on up there was smart and sensible. The first lunar travelers also knew pretty much from previous experiments what to expect. Otherwise, a trip to the Moon would probably have meant a death sentence without gaining much additional knowledge. And mankind would have lost its desire for space travel. But indirect observations remain indirect observations. And as valuable as the theoretical knowledge is, if different cameras can mistake the same object for liquid water and for dust, then the variance of observations already on the planet's surface is still very large indeed. And if you then also use radar to characterize a structure under the surface of Mars, then you're literally walking on even thinner ice. Can we really rule out the possibility that Mars's saltwater lakes won't be mistaken for its coal reserves tomorrow? Liquid water on Mars and on other planets is a tremendously exciting topic, but it will probably only be established more precisely when the first sample can be directly examined on Earth. And if you're waiting for the first Martian colonists to visit the first underground saltwater swimming pool, you'll have to reckon with a few more centuries. The colonization of Mars is still as much a dream of the future as the journey to the Moon was for astronomer Johann Kepler. But one day, it will happen. Until then, it's tremendously exciting to follow the reports of NASA and ESA, to dream a little, and also to form a critical judgment. So once again, what do you think? We invite you to submit comments below.